Hey, hello all. In this video, we'll try to understand the basic structure of C program and how to read and write data from console. For that, what I'm going to do is I'm going to navigate to desktop, and there I'm going to create a folder called basic structure of C, and then I'll navigate to that location and open the same in VS Code. Now our VS Code is open, so I'm gonna create a file called learnbasics.c, and that's it. What I'm gonna do is I simply created the file. I'll run it, compile it and run it. To compile and run it, we need to know commands, how to compile and run it. If you see, to compile the file, it is gcc file name, and we are going to give the binary file name too. And to run it is simply dot forward slash and the binary file name. Basically, what compilation does is it will convert whatever instructions that you have written in C language into machine code, wherein the machine code will be understood by your operating system. In my case, it is Ubuntu. Ubuntu will be able to run the binary. So there is nothing in my .c file. I'm gonna compile it. Dot O. I'll give learn basics. So there is nothing here, you can see, right? But once I compile it, you'll be able to see the binary file popping up. Okay, it is telling that, hey, I'm not able to find the main function. So basically, every C program that you write, it should have a function called main. So the compiler will start executing the code, whatever you've written inside this function. That is what is telling I am not able to find the main function. So I simply wrote main function and then again compile and see what happens. This time no errors, but you can see the binary file has also come up, and there is only one warning. It is telling that return type defaults to int. Normally every function in C language will have a return type. Okay, if we are returning nothing from this function, returning is nothing but this is how with a return statement we'll return something. We can return an integer, we can return an array, we can return a character, but if we don't want to return anything from our main function, what we are supposed to do is we are supposed to put void. Okay, so I'll simply put void. Still there is nothing inside my main function, and we'll try to compile it and run it. Yes, success, no errors, no warnings, but the binary file has come. We'll try to open it, and the editor is telling that, hey, it is either binary or uses some unsupported text encoding. I'm not able to open this, but the operating system knows how to run this file. So I'm gonna run it by simply writing dot forward slash learn basics, and nothing has printed. It's because our main function has nothing inside it. Basically, what exactly happened is the program execution started from main function, so it went into this line number 3 and it found nothing, and simply the process stopped executing. That's it. So nothing has been printing or printed on the screen. Now what we're going to do is we are going to print something. Okay, the famous statement, that is hello world. Okay, hello world. I'm going to put exclamatory, and every statement, okay, line number 3 is a statement, ends with a semicolon in C language. And now again I'll compile it, and again it is throwing a couple of warnings. Okay, it is telling that printf it's telling that implicit declaration of function printf. So it is also telling that include stdio.h. Basically, printf is a function to print whatever you want to print on the console, but the compiler or it's not knowing what exactly I'm supposed to do with printf. I don't know what is printf is. So for that, what we are supposed to do is we are supposed to include a header file. So this printf function definition will be inside this stdio.h header file. So in the C course, or as you progress, you'll try to write your own header files and try implementing the same. Okay, it's not only stdio.h. There will be other header functions like math.h, particularly when you're trying to do square root, because somebody has written that function and actually placed in that header file. You don't have to reinvent the wheel and start writing the code for finding the square root and power, 2 raised to 4 or 2 raised to 5. You don't have to do that again because it's already there in math.h. All you have to do is you have to include that and start using in your code. And also you can use under header file called standard library.h, wherein you can actually use memory allocation stuff, wherein if your program wants to be or needs some memory to be allocated, then you can use this library. But in our case, we're going to use only standard input output.h, because printf function definition will be there in this header file. Okay, now what I'm going to do is I included the header file. I'll compile once and see. That's it. No errors, nothing. So I'm going to run it. So this time I should see hello world. Yep, I can see hello world, but the output is not clean. Okay, because again the prompt or the control is coming here. For that I can give this new line character. What happens is this will actually introduce a new line. So once this hello world is printed here, a new line will be printed. So obviously this control will come down. So let's try to compile it, execute it. Yes, now the output is clean. Now I am gonna print like numbers. Okay, I can print 124 semicolon. Again, I'll give the new line so that the output will be neat, and I can give 10.05, and I can simply compile and execute it. Okay, the output is like 1234 and 10.05, and basically, but these are strings basically. But what if I wanted to print a number? Okay, for me to print a number, I need to actually use format specifiers. Okay, here in my case it is 10, right? So 10 is a number. In C language we'll call it as integer, and for integer the format specifier is %d. Okay, but basically you might ask what happened in this case. Printer, we are not giving any format specifier, but basically we are supposed to give %s, the format specifier for strings. Here also %s. But even though if you didn't give, it's okay, because by default it will actually take %s. The compiler will take %s. So even though if you don't give, it will not throw any errors, and you can see 10 has come. But for %d, if you don't give, then it will throw an error. We'll check that case as well. So what I'm going to do is I'm gonna remove this %d and directly give 10 and see what happens. So it's telling, hey, printf 10 is integer, and basically I'll default to %s, but this is not a string, so I'm throwing a error. Okay, I can't actually proceed further. That is what it's trying to tell. But basically, if you carefully observe here, this is a warning. This is also a warning. Basically, warnings can be ignored if there are any warnings, but still the binary file will be generated. So in our case, a binary file is actually generated. So we'll try to run it and see what exactly happens. And hello world has come, this one, and 1234 has come, 10.0.5 has come. But coming to here, see, it's clearly telling segmentation fault, core dumped. So with warnings, you can still generate the binary file and can run it, but you will see these runtime errors. Okay, now we'll see some fundamental data types in C language, like int, okay, to store the integer type of data. Okay, numbers like 1 2 3 4 and -1 -2 -3. Okay, in order to store non-decimal numbers, you're going to use integer data type, and in order to store characters, or character in this case is B. If it is characters, then you're going to use array, but we are going to discuss about a single character here. And if you want to have floating numbers, particularly when you are developing banking applications wherein money is involved, definitely dot something will be there, particularly when you use the credit cards. Even the paisa will also make a lot of difference, right? So in that case, the data type would be like float, and we can also have double. So once we'll finish up this, and then we'll discuss about double. So basically so a is a variable of type integer. So in a variable we can actually store integers or numbers. Here b is a variable of type character, wherein I can store character in this variable. And also c is a variable of type float, so I can store 10.25, 10.34, or floating point, or decimals, okay, in our case. Basically each this data type has a size, okay. So let's try to printf, and we'll remove this, okay. I'm gonna uncomment, and okay, we have this thing called size of int equal to percentile d size of a, okay. But size of returns, the format specifier for size of e is like lf, okay. And I'm gonna give for char, and this is for float. I'm supposed to give b and c, and let's try to compile and execute it. Oh, it is telling it's of double, okay. Format lf expects argument of type double, so we are supposed to give ld, not lf, okay. And then we'll, no errors this time. I'll run it. Now you can see again the output is not clean, so I'm gonna add new line, and new line, and I'll compile it, run it. You can see the size of int is 4 bytes, okay. 4 bytes means 4 into 8, 32 bits, and here this is only 1 byte, and here float is also 4 bytes, but the only difference is integer you can't actually store decimal values, but in float you can actually store decimal values. What if my number size is more, okay, like I wanted to store huge numbers, then I might need another data type apart from float. So in that case we can actually use double. So depending on the problem or the business logic that you're trying to write, you will actually try to define your data accordingly. So here I'm going to give d, and this is double. I'll compile it, run it. Now you can see that double has 8 bytes, okay. It stores larger values than float and integer. What we're going to do is now we are going to read some data. So in order to read data from the console, all we did here was we are trying to print the data to the console, but now we'll try to read the data from console. For that we will use a function called scanf, and again this function's definition is there in stdio.h. So scanf, I'm going to read values into a, b, c, d, okay. So I'm going to store it in address of a. What exactly is happening here is, okay, the value that we are storing will be stored at the address of a, okay, and the format specifier is percentile d. So I'm going to give b and c and d, and the format specifier for b is, okay, it's c, and the format specifier for float is f, and here it is lf. Okay, we'll try to read, compile and run it, and see the control actually stopped here. So my control actually came here and declared these variables, and printed all the stuff that I have written here. And now at line 22, it stopped. It's waiting for the user to actually enter the input. These kinds of things we'll mostly see in the ATM centers, right? It will stop there, I choose an option, it will wait there, it will wait until we actually choose an option and click there, right? Then it will move forward. Likewise, it is waiting for the input that we are supposed to give. So as it is integer type, I'm going to give 10 and I'm going to give v. Okay, the problem here is when it percentile c, I pressed enter, right? So that is considered as a character. So in order to avoid that, I'm going to give percentile c and then run it, and it waited 10. I'm going to give v character and floating point some 20.14 and double. It's a large number, right? I can give anything. Enter. That's it. We read it. Now these values that we have entered are actually stored in these variables a, b, c, d, but we are not able to see because we are not printing them. We'll try to print the same and see whether it is being stored properly or not. Okay, I'm gonna copy all these 4 statements and paste it here. Use multi-select option in VS Code. Printf a, b. For the output to be clean, okay, I'm gonna put new line and I'll remove this extra space with an extra space. Okay, now we'll compile and we'll run it. It waited there. I gave 10 and I gave some character and float. I can give 12 dot some random numbers, and then it's large, right? I can give some large values, and here you can see whatever we have given 10 has come, I has come. But here if you carefully observe, float will actually try to print only 6 digits after the point. Okay, so what actually happens here is it is trying to round it off to 6 digits. Here also same things happening. So if I only wanted to print 2 digits, okay, I can simply give 0.2 and let's see what happens. We'll compile it, we'll run it. 10 u. Now you can see that, right? So it's rounded off to only 2 digits, 24.99. So we'll quickly recap what we have learned. So our compiler should actually will actually look for the main function in your C program. So we are supposed to write the main function, and if nothing we are returning from the this function, then you can actually give the return type as void. And also we learned how to actually read and write data from the console and to the console. For that, these function definitions will be there in standard input output dot header file. And also we'll try to put some return thing, okay, in, as this is integer type. So we will try to return an integer value here, okay. We'll try to return integer value and we'll compile it. Nothing, basically logically we didn't change anything. It's same as previously only. Same thing, nothing changed, only the thing is we are returning 0. But what happens if I actually keep return 0 here? Because understanding return is also really important. This is basically basics, okay. For to write any C program, this video is very essential for you or for anybody. Okay, see, it printed here. My control actually came here. It declared and defined all these variables, and then it printed this, and my control came here. And finally, the moment it encountered return 0, the control returned. So all these statements were ignored. You got it? So basically, if you won't put a return statement here, but you're expecting int here, and we'll try to run the program, no errors. It's working as usual, okay, no issues at all. It's because what happens is this C compiler, when it reaches the end of this function and encounters no return statement, by default, as it is integer, it will consider integer type. You got it, right? So return statement plays a very important role. For suppose you wanted to return the control from here itself, you can simply put return 0 and try compiling. Only hello world will be printed. hello world. That's it. So these all statements ignored the control. From the moment it hit here, it exited this main function. What if I wanted to have void and still I wanted to execute only hello world, and I don't want to execute these steps? In that case, I can simply put return followed by semicolon. I'll compile it and run it. You can see. And if I wanted to print these statements as well, I'll give return statement here, compile it, run it. Chalo, it printed till 10.05. Okay, so return statement is very important way to understand. If we don't want to execute these statements, we can keep here, or if we ignore it, by default compiler will assume there is a return statement at the bottom of your C function. And thanks guys for watching this video. If you like this content, please do like the video, share and subscribe. It will motivate me to make more videos like this.